Hi, everyone. My name is Patrick Gray, and I'm a PhD candidate in the Marine Robotics Remote Sensing Group at the Duke Marine Lab. I'll be discussing some work on remote sensing of physical biological interactions off the coast of North Carolina. To start off with some background, the distribution of productivity and diversity across the Gulf Stream front hasn't been measured below the scale of a few kilometers. This scale spatially of a couple to a few dozen kilometers and temporally from a few hours to a few days is critically important because it is when the physics matches up with the spatial and temporal scale of biological processes of phytoplankton, such as reproduction. For example, with sufficient nutrients, many phytoplankton can double their population every day. Additionally, the ocean is generally vertically stratified. It's easy to move horizontally, but really slow and difficult to move vertically. But at this fine scale, in some areas, vertical velocities are much higher. So to summarize, the dynamics of the ecological and physical environment at this scale just aren't well understood. The Gulf Stream off Cape Hatteras is both a known biodiversity hotspot and a hotspot of these kind of fine scale physics, making it an ideal observatory to monitor these biophysical interactions. But this scale is incredibly challenging to observe. There's a real blind spot between our satellite monitoring capabilities and in situ work using ships or autonomous platforms. Towards addressing this gap, I've been using both new Landsat and ISS-based ocean data products and developing an approach using drones to diminish this blind spot. I'll be reviewing some preliminary analysis using this data on productivity and the physics across the Gulf Stream front to address one main question. Does the front itself contain a phytoplankton community that is distinct from the regions on either side because of the unique physics that are there? So drones and satellites with multispectral sensors can measure ocean color, which in turn can lead to accurate estimates of chlorophyll concentration in the ocean's surface layer. At its simplest, you can think of this as measuring a ratio of blue to green, with more green meaning more phytoplankton. That change in color happens because the chlorophyll pigment in phytoplankton absorbs more blue than green, as you can see here in the green absorption spectra. And this makes the water greener. Our eyes can see this, and with a science-grade spectrometer, we can precisely measure this change in color. So using that basic idea, let's take a look at the Gulf Stream here. This is a new USGS product for Landsat 8 that more accurately measures ocean color. And you can see this really intense color change across the Gulf Stream front. So running that multispectral data through NASA's chlorophyll A algorithm, as well as pulling in band 10, which is a thermal band, we have chlorophyll on the left here and sea surface temperature on the right. And as you move offshore, this is Cape Hatteras right here, you can see the intense step change from high to low chlorophyll and cold to warm water temperature. And if we zoom in on this spot on the front, we can see these many fine scale features that become apparent in both chlorophyll and sea surface temperature. Here's another example, this time from EcoStress, which is 70-meter data. And it's a relatively new International Space Station-based thermal radiometer. Zooming in on that data, you can really see some of the physical conditions that you can find along the front and interesting features there, like eddies and filaments and streamers. And so while the sea surface temperature data certainly hints at fine-scale features peeling off the front that could well contain communities from either side or from the middle, and that there's some really interesting stuff going on there in the front itself, we can't actually get it diversity. The Landsat sensor isn't built for ocean color and doesn't have enough spectral resolution or sensitivity to differentiate these phytoplankton communities. And the sensors that do have the proper spectral resolution are far too coarse spatially. So it's really infeasible to tease apart whether or not there is a potential community in the front. So to help resolve these questions, I'll be going out on a few trips this year using drones to provide ultra high resolution thermal and multispectral data across the front in this region. And so really, as for whether or not there is a unique community to the physics of the front, you'll just have to stay tuned for more information. And to conclude, I want to say thanks to everyone who has and continues to support this work. And please follow up over email if you have any questions.